At the same time, the red figure shows SE level 1's blue splits. Between 2 and 4 minutes, SE level 2 and 3 splits on elapsed time in the red figure. In the same time, smoke spreading and falling below 4 meter high in the right figure. 6 minutes later, smokes fall below 1.5 meter high between x equal 200 and 300 meters. Also in the red figure, same area is SE level 6. 8 minutes later, smokes fall below 1.5 meter high from x equal 200 meter to right exit. Also in the red figure, same area becomes SE level 5 to 7. 10 minutes later, smoke spreading along an upslope and falls down the floor in the right figure. Also in the red figure, almost an upslope becomes SE level 7, result between x equal 100 and 200 meters. So we can reach smoke spreading and descent places every moment from this map. This slide shows the evacuation simulator's flow. First of all, this simulator reads the initialization, for example, tunnel space, assessment time, SE levels, evacuees walking speeds, and etc. Second, this determining SE levels from CFD analysis every moment. Third, the occupants evaluate the situation in the simulation, which are SE level 1, seeing evacuating people, and listening to emergency announcement. Fourth, they prepare for the evacuation between 5 and 15 seconds, and then start it. Fifth, this simulator reads the variation of their walking speed depending on SE levels and makes their location shifted. And if they are surrounded by thick smoke, we determine the number of them in the simulation as the number of people requiring help and PRH. Time marches on. Finally, coming the assessment time, this simulator finished the simulation. We use the assessment time as 10 minutes when ambulance services arrive at the tunnel exit in Japanese urban areas.
2 minutes.
We made an evacuation behavior map from the smoke environment map of last slide, combine the evacuation simulation. The black lines are the occupants' behavior. After that, they evaluate the situation before I said, they start to eat. And then almost of them can finish it, but one of them cannot finish it in x equal 400 meters. We define them, people requiring help, PRH, who surrounded by thick smoke, become impossible to move anymore and stay the place. So PRH are not victims. We assess using the number of people requiring help and PRH. Since this slide, it shows an example using the assessment method. But today I don't have a time to explain the results, so please read the paper. This is conclusion. Thank you for your kind attention.
So, questions, please.
Yeah, I'm very interested in the topic because it's my main topic of PhD. So, my question is, first of all, maybe it was my fault, but I did not get how you were considering the correlation about the visibility and the speed of occupants. How did you consider the correlation between the visibility conditions that you were tracking in your model and the speed of occupants? You were just considering I mean, that people will stop.
Stop,
at a
yes,
certain
stop.
point. But we know that we have a correlation for people walking in different disability
Yes,
conditions. So I did not get this point.
I searched about your ideas. So I did. I have considered your ideas, and this difference is not so big. So our
I mean,
results.
today I was showing the two data sets on this topic with the two different possible correlations between disability conditions and walking speed. So you're at the assumption that after a certain point, people will stop, but how to define this point? What is your limit?
Density. What density will they stop?
Yes, density and stop. And then, so your idea is so good. And this is next issue, next to my issue.
Okay.
So thank you.
And the second point, I did not get, what is the movement model you were using? So how do you calculate speeds of different, you were just saying that you were using random inputs, but so you refer to random inputs to movement speed. Okay. And about the pre-movement times, I saw you were using from 5 to 15. But
yes.
we have cases with 4 minutes waiting, 5 minutes waiting.
Yes.
So
Yes.
we're thinking of implementing,
Yes.
different.
I hope so. This is my hope. So it is actually I think what you said, but this I'd like to get most safety results.
But this is opposite. Because
Yes.
if you say that people is moving after 10 seconds, and I'm saying that people is moving after 5 minutes,
Yes. So this is my
this is
hope.
not a conservative.
Yes. So we have to advertise and inform the tunnels dangerous.
So
This is my hope. Thank you.
do we have any other questions? Yes.
In your simulation, you have the speed of movement of the smoke. I think you're using 1 meter per second. Speed along the tunnel. Flow.
Or was it the
Natural
ventilation?
Natural ventilation is 1 meter per second.
Right, yeah. So this is a critical number because if walking speed is 1.2 meter per second, the people will go faster than the smoke. If the smoke goes at 2 meter per second, then many people will be trapped by the smoke, which is what we found at Mont Blanc, because the velocity of the smoke starts at 1 meter per second and then goes faster and faster. At the tunnel mouth, it's 5 meters per second. So it depends on your assumption on the flow in the tunnel.
Yes.
Any other questions? If not so, I will remind that we will have the group photo taking in front of the building, so please go to the entrance hall before you go to the lunch. So let's go to the photo. Thank you.
Thank
And
you.
let's